talk about mastermind. So what is mastermind? So mastermind can be played between two people. So let's just say um, this person hides certain numbers, right? And we have to guess what those numbers are. So there have to be four characters or four numbers. So let's say we are the one that is guessing, and let's say we guess that it's 1, 2, 3, 4. And let's say this person reveals the numbers. Let's say this person reveals that it is 1, 3, 5, 5. So now, how many are correct? The one that is correct is this one because they're the same and they're in the same position. So it means correct will be, okay, so correct, forgive my handwriting there. Let me just correct it a little bit. So correct is equals to 1 and correctish. So correctish. So how many are correctish? So the ones that are correctish are the ones that are the same but in the wrong position. Notice that these ones are the same but they're in the wrong position. So then it has to tell me correctish 1. So the ones that are the same but in the correct position is correct. Then the ones that are the same but in the wrong position is correctish. So I want to create a function that will take, let's say, the one that was hidden as x, right? Let's take it as x. And the one that is from the guesser is y. So I want to create a function, let's say mastermind. So I want to create a function called mastermind that will take in two arguments. It will take in x and y. And whenever I run this function, it must tell me how many are correct and how many are correctish. But I want it to return the answers to me as a dictionary. I want it to give me a dictionary that will be written correct. It will tell me how many are correct. So for instance, here in this case, correct is 1. And how many are correctish. So how many are correctish, then it will tell me 1 also. So I want to create a function that will take in two arguments. It will take in the value from the one that was hidden and the value from the one that was guessing, and must tell me how many are correct and how many are correctish in the form of a dictionary. All right, let's define mastermind. Let's define a function called mastermind. So whenever we use the EF, we are telling Python that we are creating our own function. So let's define a function called mastermind. Let it take two arguments. Let's say this one is from the one that is hiding, and let's say this one is the input from the guesser, right? The person who's guessing. So let X be the one that is hidden, and let Y be the one that is from the guesser. So we want to create correct and we want to create scores for correct and scores for correctish. So let's just say correct. Okay, so correct equals to, so what basically is going to increase each time we find something's the same and in the correct position. And then this one is going to be correctish. So correctish. So correctish also equals to 0. So every time it finds something that is the same but not in the same position, then correctish will start increasing by 1. So then we're going to say for I in range. So why am I using range? I want to access the index of both lists, right? So that I can compare both of them at the same time. So we know that the length is going to be 4, but let's just say length of y. So remember, y is the one from the guesser. So we're going to say length of range length y, right? So that is going to check index 0, index 1, index 2, index 3, right? So what we're going to do is that if x in that specific index, right? So let me just put if. So we're going to say if x in that specific index, right? So if x in that specific index is equals to y in that specific index, right? So then we're going to, so then correct must be increasing by 1. So correct, we'll say correct, okay, not cool, correct plus equals to 1. So that's what's going to happen. Every time it finds that x in that position is the same as y in that position, then correct will be increasing by 1. So now we have to deal with the correctish part. So what we're going to do is that we're going to check, we're going to make x into a set, right? So let's just do that. Let's just call it maybe the set of the input. There is a reason why I'm making x. So let me just do this, the set of the input. So why am I turning it into a set? So let's do this. So the set of input, let's just say this is equals to, so we're going to turn it into a set. Whenever we want to turn something to a set, we have to use the set function. All right, why am I using set? Why am I using set? So the reason I'm using set is, let's just say the one that is hidden is 1 1 2 4, or rather 1 1 2 1, and let's say the one that we guessed is, let's say 3 4 1 2, right? So now notice, if I use a for loop, it's going to check if this exists in the other one, right? So notice it does exist, but it's not in the correct position. So correctish will be plus or equals to 1, right? And then notice, since the for loop, it's going to check this one. Now it's going to say, does one exist in the other one? Yes, one exists, so it's going to count 1. Then it's going to count this one doesn't exist, then it will look at the next one. Then does it exist in the other one? Yes, it does. Then it's going to count 1. But notice, we're only supposed to look at each item once. So it counted it 3 times, even though this does not exist 3 times in the other one. Notice that only one of them is in the other one, right? So we have a problem. So basically, when we're checking each item, we want to check each item once. So because we want to check each item once, that's why I use set. Set only makes it into a unique, makes each element unique. So for instance, if I say set x, what's going to appear in the set is 1 and 2, literally. So we don't have duplicate inside a set, right? So whenever we've got numbers or even letters, let's just say A, B, B, let's just say A, B, B, C, C, C. What's going to happen is that if I turn this into a set, inside the set is only going to be A, B, and C. So inside the set, there is only unique elements. So I'm converting this into a set so that when I use the for loop, it will only consider each item once. So that's the purpose of using a set. So now the thing is, what I want to do with the set is this. Notice that we have, okay, let's just do this. I just want to show you something. So when I consider the set, is only going to look at 1 and 2, right? So basically, my plan is to say how many times does 1 appear here and how many times does 1 appear here. Notice that 1 appears here 3 times, 1 appears here once, right? So I have to take the one that is the smaller one between the two, right? So which is 1, then it will be correct. That's how it is. So basically, we always need the minimum of the appearance. So then when the for loop now goes to 2, it's going to check how many times does 2 appear here and how many times does it appear here. Notice it appears here only once, it also appears here only once. And when I take the minimum of them, it's just once. So then that's the correct way to do it when it comes to correctish. So that's how it is. So basically, I want to consider each unique element and I want to ask how many times does it appear in X and how many times does it appear in Y. And then I want to take the one that is the smallest of the two and then count it as correctish, right? So that's the plan. So I converted it into a set so that I can loop over it, each item only once. So then I'm going to create a for loop that will loop over that item. So then I'm going to say for I in set input, right? So for I in set input, okay, you can call it anything you want. I'm just calling it set input. So for I in set input, what I'm going to do is that I wanted to check only I wanted to count how many times does it appear in X and how many times does it appear in Y. So what I'm going to do is that I'm going to say X dot count. When we use the count function, it counts how many times each item appears, right? So I'm going to say X dot count, right? I wanted to count I, right? So I wanted to find out how many times does it appear. So let me just say appearance in X, or let's just say X appearance. So let's just say X appearance. So X appearance. So it must there must be X appearance and also Y appearance. So I'm just calling it this. You can call it anything. So I'm just going to say Y appearance. So let's do that. So Y appearance. Alright, so then it's going to count. So this is equals to, okay, not cool, I meant to say equals to. So equals to y dot count. So whenever you use this will count how many times does it appear. So that's how it is. So it's going to be y dot count. So when I find the count, right, then what it has to do is that it has to be, let's just say the minimum appearance. Yeah, let's just say minimum appearance. So, or yeah, let's just say appearance just. So the actual count, the actual one that we should be counting is the minimum of the two. So then we're just going to say it is minimum. So minimum of x appearance and y appearance. So minimum of x appearance. So let's just do that, x appearance. Okay, so let's just do that. So okay, not cool. So x appearance and y appearance. So we wanted to return the minimum, the one that is the smallest of the two. Remember, there is the max function that will tell us the maximum, right? And then there is the minimum. There's the min function which will tell us the minimum. Let's just make this into a list. When you put square brackets, we're actually making it into a list. So let's just do that. Okay, so let's make it into a list. So appearance will be the minimum of the two, right? So then we're just going to say correctish. So correctish will be equals to, we'll just say correctish plus or equals to the appearance. So then every time it counts correctish, every time it finds the appearance, it's going to add it in correctish. So it's going to be correctish plus or plus equals to appearance. So that's what's going to happen. So yeah, that's what will happen. So now let's talk about the final result. So we wanted to return a dictionary, right? So the final result is going to be, so if we wanted to return a dictionary, we can create our own dictionary. When we do this, we're immediately creating our own dictionary. So our own dictionary should have correct. So should tell us that correct. So we're going to put it in, it's a string. So we're going to say correct. And then we're going to say, okay, so we're going to say correct is equals to what we got incorrect, right? So what we got incorrect. And then correctish, so let's just do that. So we're going to say correctish okay, not cool, not my intention. So correctish. So then this will be, so it should tell us that correctish. And then now notice, we can say it's equals to correctish, but I'll show you a small problem. The problem with correctish, okay, let me just see, yeah, let me just show you the small problem with correctish. Alright, so now let's just say the one that is hidden is 1121, and the one that is guessed, let's just say it is 3 1, let's say maybe 2, and let's say, yeah, let's just say 1. Alright, so for example purposes, let me change one thing. Let's say this is 1, and let's say this is 4. So this is the one that is hidden, this is the one that is guessed, right? So how many are correct? Notice that the one that is correct is only this one because they're the same item in the same position, right? So far we know that correct is 1, right? How many are correctish? So since this has already been counted for correct, for correctish, this we can only match this one. So correctish is 1. Even though there's another one, we're not allowed to count it because this one has already been used for the other correctish. So basically, we know that the correct answer for correctish is 1, right? So correct 1, correctish 1. But now let me show you something with the method that I used so far. So remember, I'm considering the set, so it's going to check in the set. So in the set, it's only going to be unique elements, 1, 2, yep. So it's going to check how many times does 1 appear here. 1 appears here 3 times. How many times does 1 appear here? 1 appears here twice. It's going to take the minimum and it's going to say the minimum is 2. So notice it's telling me that correctish is 2, while we already agreed that correctish is 1. Why is it telling me that it's 2? It's because this method does not exclude correct. This method also includes correct, right? So notice, because it's also counting this one, even though this one is part of correct. So whenever I use this method, just be aware that it counts correctish, but it also includes correct. So for it to count correctish only, we have to say the real answer of correctish is equals to correctish, right? Correctish according to this method that we're using. So correctish minus correct, so that it can exclude the one that is correct. So remember we said correct is 1 and the real value of correctish is 1. But if we don't know the real value and we use this method, it's going to tell us correctish is 2. But now if we say correctish minus correct, it's going to give us the actual value that we figured out already, right? So for us to get the real value of correctish, we have to exclude correct, because this method that we're using also counts correct. Notice that this method tells me the minimum appearance of the 2 is 2. And then correct is 1. So if we just exclude correct, we're going to get the real value of correctish. So that's what's happening. So therefore the real value of correctish is equals to correctish minus correct, right? So we can just say it must be correctish minus correct. So correctish minus correct. So that is the real value. Okay, so we're going to test if our code is right. So yeah, this is what we have here. So let's test it. Let's create a variable. So let's create a variable. Let's call that variable maybe, let's just say x is just this. So let's say our guess is 1 1 2. Let's say the hidden one rather is 1 1 2 1, and let's say our guess is, let's say it is maybe 3 1, and then let's say 1 5. So according to this so far, I know that 1 is correct, right? Because notice in the second position of each that the same, right? And then we have another 1 that is in the wrong position. So correctish must be 1, correct must be 1. So let's just test it and see. So let's just print it. So let's just say print mastermind. So print mastermind. So print mastermind xy. So x comma y. So let's just see if it's going to give us our expected value. Okay, so let's see what error did I make. Okay, matter of fact, this is supposed to be a string and not an integer. So with integers, the length function does not work, right? It only works with strings. So it works with strings and lists and even tuples, but it doesn't work with integers. Okay, so let's just see so far. Let's check it out. There we have exactly what we wanted. It tells me correct 1, correctish 1.